Hi, hello friends. Welcome to my YouTube channel. Now, in this session, we will discuss the electrical transients. Okay, so what is the meaning of transient? So, transients are considered as sudden changes in the state of circuit or network, which are indicated by switching operations. That means a sudden change in the values of current or voltage is nothing but is considered as a transient. Now, in it occurs in any electrical network, either it may be series RL or series RLC or parallel RL, parallel RLC, any network or any system. Okay, either it may be electrical system or any mechanical system, as none of the system are adaptable for quick sudden changes in time. Why? Because every system has its mass. Suppose, for example, if you consider RLC circuits, we will have two elements, inductor and capacitor, which will not change their behavior instantaneously. So though the transience occurs for any short duration of time, so it occurs for very short duration of time, their impact is huge in determining the entire steady state response. So I would like to give an analogy example point of view. Suppose heart attack. Okay, heart attack occurs for very small period of time, but it may cause to death. So like that, similarly, the transients are very short period of time, but it may cause damage to the other equipments or the equipments present in the network. So the transient analysis is very important. So that's why the designers are majorly focused on transients in the networks. Come to the next slide. The complete response of a system is a combination of, what is a complete response? It is a response of combination of forced response plus natural response. So what is the meaning of this forced response and natural response? So forced response is nothing but it is because of steady state response. That means the network has attained its steady state, a constant. Okay, it is also known as final response. It is also known as final response. So these all are because of if there is a source is present. Okay, so response is independent of nature of elements. So here the nature of element means inductor will store some energy, capacitor will store some energy, resistor will dissipate the energy. It depends. So here it doesn't matter. In case of natural response, so natural response, the transient response is nothing but it is because of source free response. Okay, so source free response means there is no source present. So source is absent here. The response is independent of source. That means it depends upon the nature of the elements, the element how it's going to store its energy and discharge its energy, right? So what are these switching timings? So for example, say at t is equal to 0, I am operating this. Here I am closing the switch. So arrow direction is very important. So arrow direction is downwards means this switch is going to come like this. Means this contact is going to be move in this direction so that it is going to be conducting. Okay, so here when I am closing the switch or operating the switch, what about t is equal to 0 minus means suppose now the time is suppose for example say some hours 30 seconds. So 30.00 seconds. So t equal to 0 minus means 29.99 seconds. T equal to 0 plus means 20, sorry, 30.01 is nothing but the time period. So t equal to 0 minus means just before operating the switch. T equal to 0 plus means just after operating the switch. So we are assuming that at t is equal to 0 minus the network is attained its steady state. Similarly, at t is equal to after 5 time constants, very important, 5 time constants, the network attained its steady state. So in between the transient state occurs. So the time limit for the transient is in between t to 5 time constants. So we are going to find this time constants for different circuits, RC circuit and RL circuit. So a t is equal to 0 minus instant just before switch operation, the network has as its attained steady state. So we are going to see how the network elements is going to behave in steady state. So t equal to 0 plus means the instant just after switching operation, the network undergoes transient state. So for how much period of time it will remain in transient state? it is depends upon the time constant of the network. So it is hardly from 0 to 5 time constants of the network. So after that the network again gain its steady state. So at t is equal to infinity, the network has attained its steady state. So t is equal to 0 minus means steady state. So t is equal to 0 plus means it's a transient state. So t is equal to 5 time constants more than that means we treat them as t is equal to infinity so that the network attains its steady state. Next slide. So in the next slide, so we would like to discuss the passive element properties. So passive elements are resistor, inductor and capacitor. So here I am not going to discuss about resistor. Why? Because we already discussed the resistance in my previous lectures. Now here inductor. So what is the inductor? Inductor is a property of a coil to which it opposes the rate of change of current through it. So it will store the energy in the form of electromagnetism. That means it will create north pole, south pole here. Okay, and it stores the energy in the form of magnetic field. So which is mathematically given by half L I square. Okay, so energy, as we know that as per the law of conservation of energy, energy cannot be created or destroyed. It can be transformed from one form to other form. So energy cannot be changed suddenly. So energy cannot be changed suddenly. It requires impulse effort. That means sudden variations. So at t is equal to 0, so we should get infinity. Such a t equal to 0, we get magnitude is going to be infinity. Such a type of signals we have to apply. So practically it is not possible. Okay. So inductor, the main property inductor will not allow sudden changes in current. Why? Why? Because inductor already stores its energy in the form of current here, electrical current. So energy stored in the inductor is proportional to I square here. So current square. So as we know, energy cannot be changed suddenly. So I cannot be changed suddenly here. It allows, but it allows sudden changes in voltage. Okay, so here these are the variable in inductor. What is a variable? Variable is nothing but voltage. What is a constant? The constant is nothing but current. So VL is a voltage across inductor is equal to L into di by dt. So at t tends to infinity, that means this part is going to be infinity means, okay, so VL is going to be 0. So if VL is 0 means we can according to electrical properties we can treat it as a short circuit. So short circuit is nothing but the voltage is 0. Next slide. So capacitor is also similar to inductor. Inductor, now here the energy stored in the form of electrostatic field. So electrostatic field, that is the formula is given by half CV square. So as we can say, energy stored in the inductor is proportional to voltage square. Okay, as we seen just earlier, in case of inductor it won't allow sudden changes in current. Here capacitor won't allow sudden changes in voltage. So it won't allow sudden changes in voltage, but it can allow sudden changes in current. So IC is equal to C into dV by dt. At steady state condition, we will treat t is equal to infinity. That means t is greater than 5 time constants means we can treat it as a infinity only. So IC is going to be 0. Capacitor act as a short circuit. So remember friends, while we are discussing in steady state, inductor act as short circuit, capacitor act as open circuit. Okay, next slide. So let's see the first order circuits. The first order circuit means the number of energy storage components available in distributed form in any circuit represents its order. So we are going to see next RL circuit and RC circuit. Okay, but what about this RL and LC? Why it is called second order circuit means? So observe here. So this is network consisting of only inductors and resistor here. So we can make them combination here, but because these two are in parallel we can make them parallel, and this is in series with this, so we will make a simple RL circuit. But here which is physically not separable, so not in a distributed form, it's a combined form. So resistor is in parallel with inductor. Okay, so these kind of situations it is treated as LLC circuits. So these are second order circuits. Okay, so next slide. So next we will see transient circuits. So transient circuits are classified into two parts. This is the first order and second order. So depends upon energy storage elements and their connections. It is divided into first order and second order. In first order circuit, majorly it is divided into two parts. It is RL circuit, RC circuit. So it is not a combination of series RL, parallel RL like that. We will discuss that part RC here. So, but in case of RLC circuit, we are going to divide in two parts. That is series RLC, parallel RLC. So you can ask a doubt, sir, why you are not discussing about series RL, parallel RL here? We will discuss that thing in the lecture. Okay, in this lecture. Now, so RC again here. So there are two types: without source, with source. So without source means it's a natural response or transient response. Okay, source free response. So with source means it is a forced response or final response or steady state response. So like that it is divided. Similarly, series RLC circuit, it is also divided into source free response, source. So here also same thing, source C, source free and source here. So now let us consider a source free RL circuit here. So source free means, so who is going to provide the energy to the capacitor? So already it is having some energy. That means this capacitor is already attained some energy, so that now it is having some voltage. Okay. So the capacitor is initially charged to a voltage V naught. So we are assuming that the capacitor already charged to a voltage of V naught here. Okay. Now these two are in parallel. Why? Because it is dividing in same voltage here. So the voltage across the resistor and voltage across the capacitor will be remain same. Okay. So by applying KCL here, by applying KCL at this particular node here, we can say the currents entering. So what KCL says? KCL says that algebraic sum of currents at a particular node is going to be 0. So we are treating if the current leaving to this node is positive sign, and here also leaving positive sign. So these two are added together. So IC plus IR is equal to 0. So what is the IC? So already we seen IC is equal to C into dV by dt plus V by R. So from this, if I send this V by R to the right side, then C into dV by dt is equal to minus of V by R. Now I want to eliminate this differentiation. That means I am going for some solution here. So this is the first order homogeneous equation. So by integrating on the both the sides of this equation, so integration of dV by dt is equal to integration of minus dt by RC here. So here we are going to take the limits from 0 to t. Okay, so limits are 0 to t here. So once you're taking the limits, if you integrate it, you will get the solution as v is equal to a into a is nothing but a here integration constant. A is nothing but it's a integration constant. So a into e power minus t by RC here. So how to find this integration constant a here? So by applying initial conditions, that is at t is equal to 0. So when you are not operating the switch at t is equal to 0, the v of 0 is nothing but v naught. So here it is v naught here. So v naught, v of t is equal to a into e power minus t by r. So this equation just now we derived here. Now I'm substituting t is equal to 0 here. So already assumed that at initially the capacitor is having some voltage called v naught. So v of 0 is equal to a into e power minus t by rc. So t I'm substituting as 0. So 0 here. So 0 is going to be e power 0. There is nothing but v naught is equal to a. Now I will take the complete solution. So v of t is equal to v naught into e power minus t by rc. So what is this e power minus t by rc indicates? It is source free response or exponentially decaying response. So after 5 time constants, it is going to be decay to 0. That means after 5 time constants, this circuit, this voltage is going to be 0. Okay, so as we know that this voltage is going to be 0 means capacitor act as a short circuit. So see here how it is. So time constant. So tau is the time constant which is having units of tau is equal to RC. So RC means time constant means units are seconds, or it may be resistance in ohms, capacitance in farads. Ohm farad is the other unit for seconds. Okay, so important question for those who are preparing for competitive exams. Okay, after 5 time constants, the exponentially is going to be decay to 0. That means voltage across capacitor is going to be 0. So the transient period hardly occurs between 0 to 4 time constants. Okay, that occurs transient state. So next, we will see the current flowing through the capacitor. So IC is equal to C into dV by dt. So C into d by dt of V naught is a voltage across the capacitor. V naught into e power minus t by tau. So if we differentiate it, C into V naught is a constant, we will take it outside. So d by dt of e power minus t. So d by dt of e power x means e power x into, so what is a here 1 t minus t by tau is there. So it is going to be minus t by tau here. So it is tau. So finally, I naught is equal to V naught by R. So how we got this? So tau is nothing but RC. So C by RC. So C by RC, which will give CC gets cancelled. So V naught by R into e power minus t by tau is the solution. The units are going to be its amps. So PR of t is equal to Vt of square. There is a power across resistor is nothing but V square by R. So common voltage between resistor and capacitor. That's why I'm taking V of t here. So that is equal to V naught into e power minus t by tau whole square by R. So which is nothing but V naught square into e power minus 2t divided by tau by R. So the importance of this e power minus t by 2t by tau is it indicates that the resistor, the dissipating the power 2 times faster than charging of capacitor. So 2 times faster than charging of this capacitor. So E of t, that is energy stored in the capacitor, is equal to half CV naught square, which is equal to half into C into V naught square into e power minus 2t by tau. So V naught already we know, right? So Q is nothing but charge stored in the capacitor. Q is equal to C into V. Okay, C. What is the V? V of t is equal to V naught into e power minus t by tau. So that is in coulombs. So next continue a problem here. So here we are having a voltage source of 50 volts and 500 ohms resistance. At t is equal to 0, the switch is operating here. So if you observe here, I am lifting the switch, means that is open circuited. So t equal to 0 minus means it is closed switch. And 2000 ohm resistor here and 500 ohm resistor here and capacitor is here. So it's a 1 microfarad and voltage across V. What we need to find is V of 0 plus how much, and voltage across the capacitor after 2 milliseconds, what is the value. So as we know, at t is equal to 0 minus, the network is in steady state. So capacitor behaves as a open circuit. So here if it is an open circuit means no current is going to be flow through here, as we know. So if there is no current flowing, there is no voltage drop across here. So whatever the voltage across the capacitor, it will be appears across same thing across 2000 ohm resistor. So by applying voltage division rule here, so t is equal to 0 minus, the switch is in closed position. So V of 0 minus is equal to 50 is the total voltage into 50 total voltage. And how these two are? So these two are in open circuited. So it is open circuited here. We won't do anything here. So these two are in series. So 500 plus 200. So it is open circuited now. So nothing will get count. So 50 into 50 into the resistance where you find voltage divided by total resistance here is nothing but 40 volts. Next case, at t is equal to 0 plus, what we are doing, we are just opening the switch here. So once you open the switch, this is the equivalent circuit. So 50 volts and 500 ohms is open circuited here. So t is equal to 0 and 2000 ohms, 500 ohms are here like this. So if it's open means then 500 plus 2000 are going to be in series. So why we are going to do this? Because in order to find in this expression time constant tau. So if you look from the capacitance side, so capacitance is open circuit. What is the equivalent resistance? Equivalent resistance will be 2500. That's a combination of 2000 plus 500, 2500. Capacitance is 1 microfarad. So from this we can calculate tau is equal to R into C. I can write 2500 into 10 power minus 6. It is written as 2.5 into 10 power minus 3. So we want 1 by tau here in this equation. So it is going to be 0.4 into 10 power 3. The question is V of 2 milliseconds. So V of t is equal to 40 into e power minus 0.4 into 10 power 3 into t. So when I substitute t is equal to 2 milliseconds, I will get 40 into e power minus 0.4 into 10 power 3 into 2 into 10 power minus 3, which is nothing but 40 into e power minus 0.8, which is nothing but 17.87 volts. So approximately 18 volts is going to appear across the capacitor after 2 milliseconds of time. That means it's a transient. So next we will see the source free RC circuit. In source free RC circuit, the sorry, yeah. Now we will discuss source free RL circuit. There is a first order circuit here. So here we are going to take a RL circuit. So if you observe here, I am assuming that inductor is hardly having a charge, that is a current here. So if you observe here, so plus minus, the inductor is delivering its current. Why? Because inductor will never allow sudden changes in current. So I am taking reference as a inductor current I here, so that according to passive sign convention, we are having plus and minus here. As the current entering at the passive element, we will treat with a plus sign as per passive sign convention. So by applying KVL, so VR plus VL is equal to 0. So VR is nothing but I into R according to Ohm's law, plus L into di by dt is equal to 0. So by doing integration on the both the sides, as we did in case of series RC circuit, we get I of t is equal to a into e power minus r by l into t. So how to find? To find a, I am taking initial condition. Initial condition, the current flowing to the inductor is I naught. So I of 0 is equal to a into e power 0. So I naught is equal to a. I of t is equal to I naught into e power minus t by tau, as we did in case of previous case. So previous case, v of t is equal to v naught into e power minus t by tau. Here I of t is equal to I naught into e power minus t by tau. So where tau is equal to L by R, having actually units are seconds, or it can be represented as henries per ohm, are the units of tau. So now the voltage across inductor, so it is going to be vary. So we will find how much it varies. So VL is equal to L into di by dt. Only we know I. So L into di by dt is nothing but I naught into e power minus t by tau. So minus I naught into R into e power minus t by tau. What is the meaning of minus I naught into R? Means it is exponentially decaying function like this. Okay, and it is opposite to that of voltage across resistor, as we observed in the circuit. So voltage across inductor is minus of VR, or VR is equal to minus of VL. This is what we get here. So is equal to I naught into R into e power minus t by tau. So power in the resistor, power dissipated in the resistor, PR is equal to I naught square into R. Previous case we discussed V naught square into R. Why? Because they are these are in same voltage, here same current. So I naught square into R. So I naught square into e power minus 2t by tau. So what's the important thing here is the power in the resistor dissipates 2 times faster than the current flowing in the RL circuit. So EL of t is equal to half into L into I naught into e power minus t by tau square. Okay, so we can get this energy stored in the inductor here. So let's take a simple problem. Find IL of 0 minus and V of 0 plus for the circuit shown below for t greater than 0. So here we are having a current source in parallel with 30 ohm resistor, and here having 4 Henry is the inductance and 20 ohms here. So here 4 Henry is the inductance. Okay, now so at t is equal to 0 minus, so before operating the switch, so here I am lifting the switch, means it is open circuited. Okay, at t equal to 0 plus, so before t is equal to 0 minus means it is in short circuit. I am representing a short circuit here like this. So 2 amp source, 30 ohm in parallel, and during in steady state condition t equal to 0 minus, inductor act as a short circuit. I am representing it as a short circuit here like this. So once it is short circuited, okay, the current always flows to the low resistance path. Here it will offer low resistance short circuit here. And also we can say another way. So short circuit across a resistor means it is not having any value. So I of 0 minus enters here. So I of 0 minus means, so 2 amps is a directly flowing through this inductor, so it acts as a short circuit here. So it is why directly taken as 2 amps here. Now at t is equal to 0, at 0 plus, so 0 plus, I am lift the switch, means it's open circuited here, so it is open like this. Now the current always flows in a closed path, where it starts here from here and it will come back to here again. It won't get into this circuit. Okay, but here as we know, the current flowing through the inductor does not change instantaneously. So earlier at t is equal to 0 minus, it is 2 amperes. At t is equal to 0 plus also, it is 2 amperes only. So the inductor current is flowing in this direction. So according to passive sign convention, the current entering at the passive element should be positive sign. So plus minus here. So how much voltage is here? So V of 0 plus is equal to 2 amps into 20 is nothing but 40 volts. So that is what we found here. Okay, and the last one, at t greater than 0 to find R and L. So that means we are taking the switch t greater than 0 to find resistance and R. What we'll do with this R and L, we can find the time constant. So tau is equal to L by R. In order to find this, we are taking this constant, time constant here. So current 2 amperes and 30 ohm resistor as it is. So if you look at from this inductor side is already open circuited. How much resistance is it here? It's having only 20, not this one. So when you're looking from here, what is this? These two are parallel. Okay, and there is no connection between this network and this network, so it is only 20 and inductance is 4 Henry. So tau is equal to L by R is nothing but 1 by 5. Okay, 1 by tau is equal to 5. So we know the formula earlier we discussed. I of t is equal to I naught into e power minus t by tau. I naught is nothing but 2 amperes into e power minus 5 tau amps is the answer. So thank you, thanks for watching my video. If you like my video, please subscribe and share and comment. Thank you.